Hello, today we will solve another question of GATE 2025. The question is, let gxy equals to fxy exponential of 2x plus 3y be defined on R2 where fxy is a continuously differentiable non-zero homogeneous function of degree 4, then x del g del x plus y del g del y equal to 0 holds for all points xy in R2. All points xy on the line given by 2x plus 3y plus 4 equal to 0. All points xy in the region of R2 except on the line 2x plus 3y plus 4 equal to 0. All points xy on the line given by 2x plus 3y equal to 0. So let's start the solution. Since here given that f is a non-zero homogeneous function of degree 4, then by homogeneous and by degree 4 using Euler's theorem we can write x del f del x plus y del f del y equals to 4f because the degree is 4. So this is by Euler's theorem. Now since we have gxy equals to fxy exponential 2x plus 3y, then we can find del g del x is equals to del f del x e power 2x plus 3y plus fxy into 2 e to the power 2x plus 3y. And similarly del g del y equals to del f del y exponential 2x plus 3y plus fxy 3 e to the power 2x plus 3y. Now we have x del g del x plus y del g del y equal to 0. So calculating x del g del x plus y del g del y, we can write x and then multiplied by del f del x e to the power 2x plus 3y plus fxy 2 e to the power 2x plus 3y plus y multiplied with del f del y e to the power 2x plus 3y plus f xy 3 e to the power 2x plus 3y. And if we take e to the power 2x plus 3y common, then we have x del f del x plus y del f del y plus again if we take e to the power 2x plus 3y along with fxy, then we have the remaining portion is 2x plus 3y. So now x del g del x plus y del g del y equals to e to the power 2x plus 3y into, we have already from Euler's theorem, x del f del x plus y del f del y equals to 4f. So we can write in place of that 4f plus f e to the power 2x plus 3y multiplied with 2x plus 3y. Also we can take f e to the power 2x plus 3y common, then we will be remaining only with 4 plus 2x plus 3y. And given that in the question x del g del x plus y del g del y equal to 0. So using this, if this is equals to 0, then we obtain e power 2x plus 3y 4 plus 2x plus 3y into f equals to 0. But exponential 2x plus 3y is never 0. And also in the question f is given non-zero. F is given a non-zero function. So f is not equal to 0. then only 4 plus 2x plus 3y is equals to 0. Now come to the options. So the first option is all points xy in R2. No, this is not true. All points xy on the line given by 2x plus 3y plus 4 equal to 0. Yes, this is true. All points xy in the region of R2 except on the line 2x plus 3y plus 4 equal to 0. So no, this is not true. All points xy on the line 2x plus 3y. Again, this is not true. So the correct option is B.